the one I've always had. I don't know if you're just seeing it at a different angle than you're used to, or what. Alright, so if we're gonna get this thing started, let me kick off a quick tweet. Tweet. Okay, so the tweet's off, and that's all of that. Okay, so what I've been working on today, I'll catch you up. I'm just gonna keep working on what I'm working on. What I've been working on today is I've got this situation in the main test where I need to have a good natural edits type of thing, right? I was testing inserting at the beginning and the end, which is fine, but I also want a benchmark that's like, here's an actual programmer actually programming, right? So there are a bunch of ways I could have done it, and Martin Cohen is here who has run the similar test on his code, and he can maybe tell me how he did it. But for fun, I thought I would, there was a feature that I thought I should be able to do, and it turns out like I wanted to test if I could do it, which was to run 4coder and record the session, and then just use the, like, I wrote a quick file. I wrote this for the purpose of testing, which is just a very simple prime enumeration loop. And I recorded all of that in 4coder so that I could, or I saved the result of that code, of all the edits I had to do to make that code. I saved that out from 4coder so that I could run it. So it was actual real code writing that I had, and then I was just going to repeat that several times in different parts of the file. It turns out the feature, as I was working on making it work, that it wasn't actually possible as I wrote it to make it go all the way, and I might have gone down a bad road at that point too. I had to make the decision to either go back and rewrite some of the 4coder stuff that would allow this to work correctly, and to make that happen, I would have probably been working on 4coder stuff for a day or two. Like in the editor, refactoring a lot of stuff to make it work the way I thought I could use it. Or I could write a converter that converts the shit that I actually made to the thing I thought I made. And I thought the converter would be easier, so I've written that. And it's almost done. We're going to start working on it now, making sure it works, but it still took a little while, so it might have been better to go the other way. It's hard to say. I would have had to break most of the history and undo stuff, because I thought I would be able to just take the history and make a replayable section, but the thing is because I didn't make it two ways, it's like only can play backwards. And yeah, so I had to make a thing that's like inverting it. So that's the program I'm working on now that takes a history and inverts it. It's a little tricky because there's batch edits and normal edits in the history that have to all be inverted. And inverting a batch edit's not actually that hard. It's actually easier because I do store it as a two-directional thing. But yeah, so that lesson is learned. When you store a history or an undo or something, it's probably best to just store it as a two-way thing, just because it lets you go from the beginning point to the end, or from the end backwards. So you have both options, and I hadn't needed a forwards option until now, but then I did. Now it's pain. So anyway, hopefully this is not the wrong way to fix my little issue, but because in the future I'll probably fix the actual issue. It just will take more time when I'm working on history stuff again. I'll do it. Alright, so then uh, the next thing to do is, let's see, I think I need to debug running this. Yeah, so Martin Cohen here in the chat says that he didn't actually record an actual session or use actual data. He just sort of generated an approximation with some random numbers of characters at random positions, about roughly equivalent to what a programmer does. And it sounds like a pretty good approximation. I want the replay for other reasons, so I thought I just had it, and I don't, which sucks. So, you know, it's like, learned a lesson there. But hopefully, with the stream on, I'll stop making bad decisions for a little bit and get something good done. Hopefully. Not likely, but we'll see. So yeah, what I've just recently finished doing is I've got this thing all set up to run, and I want to see where it breaks. Because I was getting a break at some point. New data, data. Well, that data is just garbage. Size. Did I fail to, like, properly end the initialization loop? I did. Wow. That's fantastic. Okay, so 245. Here I need to do a buffer end init. And that takes the init pointer. Maybe that's all it takes? Nope. Alright, so I need to look at the golden array end init. And I've got a scratch size. Oh, gotcha. Scratch size. Tote load. To render text, I use stb TrueType right now. This library here. It's a single header include library, and it's extremely easy to drop in, and I just haven't put the thought that I actually need to put into rendering. It's not really what I care about super much. I'll figure out the detail of how to render a character. I'll figure it out at some point, but it's one of those things you can easily abstract into just a single concept, and so as long as I don't spend too much time optimizing rendering or anything, you know, I'm not too worried about how to swap in a new renderer. But this was just my choice because it was so easy to do for now. Okay, so I need to find where I initialize the scratch memory and move that up so that it's available to the initialization process up here. And I'm using the OpenGL. I'm running that through OpenGL, by the way. So there's a couple different ways. stb TrueType is really great, and that it allows you to do like bitmap mode or OpenGL mode. And I think I mean I don't know any DirectX, but there's some things in there that mention like shifting bits around differently by DirectX bias versus OpenGL bias or something like this. So that means it pretty much works wherever you might want to plug it in, which is really nice. I've used the bitmap version and the OpenGL version. And those were both pretty straightforward. The only thing it doesn't have that means I might need to update some days that it doesn't do hinting. If I had hinting, that would be enough. It doesn't have hinting or subpixel aliasing. If it had just hinting would be enough for me, but obviously you could do things to get both of those. So that says it built. Let's see if it runs. Alright, still breaking at the same spot, which kind of makes sense. The data in that array shouldn't matter too much. So what's the actual problem? New data, edit provide memory, new data, new max, 65536. So here's the size of the memory we're providing. Here's the size of the thing. Yeah, that should copy into that just fine. So why is there a problem? I'm not totally understanding. Unless we didn't actually allocate. Request amount is greater than 0. No, we've totally got like a pointer right here. I'm not totally sure what the problem is actually. Copying from data, which is still fucked, so that's a little interesting. Yeah, okay, I'm gonna put a breakpoint in this initialization region and figure out why I'm not getting the kind of data in there that I would expect to see. Because it seems like it should be initializing the buffer correctly, you know? So, here's the buffer, size, and data. Right, and the data is all the junk, but we can hope that it'll be initialized soon. We've got some data there. Max is greater than or equal to size. Whoa! How is max wrong, I wonder? Let me start from the very beginningest. It might be that I need to clear buffer to 0 for this to work. Or it also might be that I need to clear init to 0 for this to work. That's almost certainly true, so I'll try both of those things. Since my policy is usually clear everything to 0, it can't hurt to clear both of these to 0. There we go. Makes some sense. And now I bet we get some better results. Okay, still found a problem, but I think we got farther. Yeah, I got to the point where it's trying to write stuff out. But it doesn't seem to like writing out now. Oh, that's too many layers of that. No, yeah, no, that shouldn't be a star there. 83. Okay, so that exited without a problem. Let's see, did we get? We got the replay data. I don't know if it's correct, and this is where it gets a little frightening that there's history data and replay data, which are both kind of opaque. So it's not easy to see if they're working. But what I can do now that will make me happier is I'll write like another utility program that'll just be a really small one that I'll write right inside the code of this program. Where the idea here is to just like loop over the replay data and print it, and let me see that it makes some sense. So let's see. Okay, let's see, I get a bit of data from a file, and file, argv1. Let's see. Yeah, so I just need to compare it to what's going on up here, I guess, and get everything out. Should just line up, come out fine. I'm always trying to think of a more clever way, because I've got another thing up there that's reading, and it's like, oh, I should start working on this big complicated thing that'll be able to handle all this file manipulation I'm doing right now, but it's I'm starting to get to the point where I just don't care to do anything fancy. I'll write some repetitive code to get something done now in a sort of straightforward fashion, and that'll just have to be good enough. So it'll look kind of like this, and I'll need 4 integers, but it's going to be a different 4 integers. I need technically what I'm doing here is building a replay structure, so I'll throw that in. I need replay count. That's the first thing I write out, and then replay children count. Whoops. And then replay children size at the bottom, and replay size right there. So that gives me my 4 sizes that I'll need, and then I just need to point the 4 pointers at the things that they need to point at. So it's like the edits goes to no edit step of the current position, and then add in the size of everything there. Then get the buffer edits, and the order here is all different out of children. I take that back, the order here is all the same. And then these are strings and strings, so they don't need this or this, and they don't need this or this, and the counts become sizes. And this needs to be children, children, children. Alright, and at the very end we can do like a quick assert that says that after all of that work, the cursor should have gone on by exactly the size of the file. Okay. Okay, so that builds a whole replay structure that I can read from, and then I just want to do a loop over all of the edits in that structure. And say if, well, let's get the edit step. Replay edits I. If that step dot first child equals 0. That's a good question. Ding ding. Child count. Whoa. Child count. Is that being handled properly? Well, I gotta make sure to zero my memory. Inverse step. okay. And then the child count will be 0 there, sure. And then does the child count show up down here? Yep, okay. So I am actually using child count correctly everywhere. That is some good news. That's encouraging. And then if the step is 0, if the count is 0, I'll do new line, and I'll track that down real quick, and then otherwise, boom. I don't actually have the ability to do that, so it's more like replace boom, boom with boom. And that first boom, boom is the step start, step end, and those are inside the edit itself, the one and only. And then the string comes from replay.replay strings plus step.edit.string start. And I won't bother to play any of the batch edits back to me because they're all just white space manipulation, so I won't really be able to tell if they're working anyway. I'll just say that there's a batch edit and move on. So let's see if that looks okay. It built, so let's see if I can run that. There we go. And replay prime replay dot RPL. Really? Oh, we're at... Can't list in this. I've gotten pretty used to my command line on the Raspberry Pi at this point, so I'm not so hot with my command line here. Replay prime replay dot RPL. That seems correct. But it, okay, there we go. Hello, NB Matt. How's it going? I'm working on a buffer experiment, as I've been calling it. I'll direct you to something that will help you find it. If you go to 4coder.net, that's the whole project. I have some blog posts here. I'm working on a text engine for my code editor, and right now what I'm doing is setting up a testing system that tests the text engine against each other, or the different algorithms for the text engine against each other for speed and stuff. I haven't really gotten to the part where I totally get down and to business and like look at the nitty-gritty of all the data that I'm collecting, but I'll get there soon. Right now I'm just setting up the last little piece of the test engine, the tester that I need. And this whole buffer experiment is open source, so if you want to check it out, you can find it here. I'll post this link since it's kind of long in the chat in case you care to check it out. And I post to that GitHub every day, so you'll be able to find code there later today after the stream. It's starting to get dark, so I'm going to switch over to night mode, where the light is on. Okay. Alright, so, you got the file, you read everything out, and then it was all, oh no, I don't understand why I got the wrong size of stuff. Size. At the end of this, I did a check that said that the size that I was outputting exactly matched the size that I output. I did a edit step and buffer edit. Did I change both of those? Uh-oh, this right here. Buffer edit. There's our problem. And that means that we're safe to try it again. That's interesting. It's very, very, very much not what I wanted to see. What I need to do is add in a size parameter here. Hello Miblo, how's it going? And this size parameter here just needs to say, hey, bro man, the string's only this long, don't show me everything you've got in whatever buffer you happen to have sitting around. That is not what I'm after. Replace. Right, at the very end I accidentally deleted a bunch of stuff and then pasted it back in one operation. But here you can see all kinds of interesting stuff, little edits expanding out with new line int C. Awesome, a new headphone socket. You'll be able to hear my amazing stream voice as I, freak out about this random junk in the middle of the shit. Okay, what's going on here? No, that's not good. None of that. I don't remember for sure, but I'm pretty sure that none of that was in this file, right? So this should just be the stuff needed to write all this. Where did all the junk come from? Now there's always two possibilities. The junk either came from the playback system, it came from the converter, history to replay, or it came from the initial history encoding. One of these things happened. Yeah, we got some serious bad stuff going on here because this junk here is overwriting what it's replaced, so that's actually worse than just I always forget what causes this. Once in a while I see it where something that is on the console overwrites something else, and it means I have a particular bug that is a pain in the ass to find because your printf debugging won't even work. But there's my guess is that it's because of this thing here, and it's because the length or the start position are all fricky, right? So what I want to do is say, look, if let's only do this if the length is greater than 0 and the string start is greater than or equal to 0 and the string start is strictly less than the string size of that string. Okay. And then otherwise, I'll just printf, well, if that, then I'll printf that we have something out of bounds. Otherwise, I'll print the same thing I print up here, less the string part. Alright, so what's going on now? That's all the same. What's going on up here? Same junk as before. So I'm not seeing any string starts out of bound, which is good news, but that means that the string itself is pretty fricked up. And I wish I could remember what causes that. It's like if you see a new line, that could be a new line in the text without a carriage return. That might be like something that happens when it gets confused about new lines and carriage returns, and it like interprets one of them in one way and not the other. Like it could be thinking it sees a carriage return, jumps back, and writes more crap, and then new lines down to this one, or I don't know. Oh, I do not know what causes that. I can't remember. I've seen it before, it's just always forget when I see it. Okay, so basically the string section has a bunch of junk in it. What I could do real quick is just say that I'd also like to see the entire string section all at once. Like, do all that work, that's fine, and then when that's done, print out the whole string section, which will go like this, right? You'll put that in, and then new line, and then new line. Okay. And the string section has to have a dot star so that I can tell it how long it is. And it's that long, and strings. That'll tell me everything in the string section of my replay file. Okay. String section. No. That can't be the whole string section. I mean, did I really write it that quickly? And where did this junk come from? There's like three little bits of junk at the very beginning. So there's definitely something wrong earlier in the system. Alright. Return 0. I write out the variables I need. I might have written it this fast just because I had written it a few times already and I was familiar with what I needed. There, I probably do a space for that. For xxx3i equals 0, I less than count, plus plus I. Oh, I know what might be causing this. So then the question is, alright, so this is coming out from beginning to end, and I also was playing them out from beginning to end, but I actually build it backwards in this one up here, right? So what I could do to help myself see what's happening is when I build it, every time, okay, do single edit, yeah, right here, okay, stack size equals new size, great, and then I just want to say, okay, after that stuff, printf, out what you just wrote. Just wrote this thing, right? Okay, and that thing will have to be size specified to size, and scratch is the string. Okay, so if I watch that while I build the replay file, I may be able to get more information. So I need to get the full version now, where I invoke it with all of the parameters. Okay, here's it going backwards, and you can see here I'm not seeing any junk, and I didn't see any at the beginning, which is, yeah, so this is, as I said, it goes out backwards, so this actually is the last thing. Like, it puts this at the end first, then it puts this at the end, like a little before that, it puts everything else right before the previous thing, and you can see there's no junk coming out here. So that means that the junk shouldn't be there so much, you know? NBMat %.s in the printf formatting scheme means that it's a string, and what you can do with anything like this is like you can say print the string and say that you want like 6 characters or something, right? You can put a number there and it limits to say print the string but stop at 6. If you didn't find the null character by 6, stop at 6. Like I don't want more than 6 characters, period. Stop at 6. Well, if you put a star there, you say, hey, I want to stop at a number, but that number is actually something I can't write the number into a string because that number is going to be in a variable, and so I want you to actually figure out the size of the string dynamically to a size that I pass you. So then you can pass a size first for the star, and then the string pointer for the string itself. So it basically says, this isn't a null terminated string, so I need to tell you the size, and I only have the size stored in a variable. I won't know ahead of time what the size is. It's got to be stored in this variable. It'll change every time this code runs, so I'll specify it as a parameter. Okay. So, with that in mind, the question becomes, why did we write out more than we actually meant to? Here I get the replay strings and the replay size. So that's where I need to pause this executing at 3:15. Okay. Whoops. Okay. Alright, Emacs. Okay, yep. Nice chatting with you. I'm gonna go hang out with Visual Studio for a bit because you're acting kind of weird. There we go. Okay. So right here, 3:12, no, 3:15. That's the one I need. Okay. Okay. So what's the size of this? 556. What's the strings pointing to? What? That's nonsense. We're writing out that as our strings. That is utter nonsense. Five, 6. Okay, so, duh. Okay, I know what's happening here is I'm writing to the end of this buffer, not to the beginning. It's like not typical C style, so I made a mistake because of that. And the mistake I made is that I can't just plop out the strings in this case. I have to go then add the whole size of the buffer and then subtract out the rest. So that's like replay.max minus replay.size, right? So that puts us in a better position, literally, inside the buffer when we read out from it, is the idea there. Ba-doop, ba-doop, ba-doo-doo, ba-doo-doo-doo-doo-doo. Because of the wonderful things he does. Okay, let's try this again. Replay string max minus replay dot size so's eyes size. There we go. And that starts right from the good part of the buffer and ends at the perfect spot. Okay, super. So I'll finish this. Shouldn't need any of those. Now let me go check. Let me switch back to the playback portion of this program. revoke that version, replace that slash prime replay dot RPL. Yes, okay, so that all seems pretty good. This seems better. Like, this seems like the right amount of stuff right here at the end, because it seems like that what I was seeing here before was too small, and I was right. And then we see there are some batch edits here and there whenever I insert a parenthesis and stuff like that. I get batch edits. New line there, new line prime. Must have copied and pasted some stuff. Some new lines there. Okay. That took up, I can't even see it all. I cannot even fit it all on my screen. Okay, so I just need to run that again and output it to, like, result real quick. I'll go take a look at that. Alright, looks like the whole thing is pretty good. Yeah, this is pretty interesting actually. You can see where, like, right here I went back to position 32 to insert a space because unlike up here, there's not a space here, right? I insert a space after this include. I forgot to insert my space after this include, and then at this point I noticed it down here. So I went back to 32 and inserted a space. And you can tell it's a space because no other line, like that's where characters start and I can go one past. Here if I go out, you can see I inserted a new line after at 44, and then I inserted the int at 44 and a main at 48 with a space after the int. This is quite neat. And the thing replaced, I inserted at the beginning in R, huh? I'm not sure that that makes much sense. You know, why would the R go to the very beginning? That's not how the file looks. And the rest of it goes here. You know, it's kind of weird. It's like maybe there's a problem with the history part now to deal with. You can see right here where I deleted a large portion with an accidental keystroke and then brought it all back, which is kind of funny. Bong. It's one of those weird things that happens when you're programming, though. So that's good. It's at least real, you know? So why is this R so weird? Is the only thing I don't get. Like, I feel like if I played this out to see everything that happens, everything would make sense except the return at the end of main would say a turn, and the R would be at the beginning of the file. You know? Like, that's the only thing that's sticking out as weird to me, and I don't know what would have caused such a weird... you can see that a lot of these actually don't merge correctly. Like, that could be caused by a type 60 T space star P R IMES. That should all merge together. The fact that it doesn't is a little bit weird, cow. Should merge. It's a little bit random, like I might have a bug in the merging system, but I haven't noticed it when I undo or use the history that it's broken, so it's hard to say. The rest of this makes sense. It's just that R is kind of random. I mean, this data is good for testing. And the really nice thing is now that I have this, I can like look into the history system more carefully and make sure that it's doing reasonable stuff, which will be good too. And as I switch it to the system where I don't have to invert it, I'll be in an even better spot. But I've got my replay data now. I don't want to get too sidetracked on debugging something that I said I was going to be kind of replacing in the future anyway. So there's a little weirdness there, and we're just going to let that be. So I want to get back to this project. Here we have a situation where I have this new shared file where I can share stuff between test main and the history to replay converter. And this concept up here of a replay needs to be visible to both types. I'm going to say that I want all of that visible to both. Round up should be available actually. Okay. Alright, so I can do that. Let's look at test main, and we gotta look here and say, okay, so this is calling it replay data, not correct. If we do replay, then take the replay file and open it, and then prepare all of the replay data there. Perfect. And then if you got that data, do the natural edits, which we'll get to later. Okay, super. So the thing to do now is I need another shared thing that's like prepare the replay, which takes in the file and a pointer to the replay structure and does the prep. And that is conveniently already written in the little else case down here. We just happen to have written it ahead of time while working on something tangential. So we can plop this in here. We're going to need to introduce a cursor pointer for the reading to work. All of this though can go. And it can be replaced like this. And then all of the cases except for this one and 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 this one, all of the other cases of replay dot just get replaced with replay arrow. So that does pretty much everything I think we need to do. To prepare a replay, we can try building, and uh-oh. Yeah, that's nuts. Oh, right. Okay, so really this here relies on a bunch of stuff. So let's pop up there and grab a hold of all of that. At that point, we're going to need the edit step itself. And the history, it all might as well just pop right here. And the test main, I think it also has some copies of these things. No, it doesn't. Okay, well, it does now. What else is a problem? Buffer edit is a problem. That's a little bit unfortunate because this code here should be getting the buffer edit actually. Unless I'm including it at a weird spot for some reason. Why would I be doing that? I think I'd be doing that for these things and that. But then it's like everything from this point onward wants to be split separately. So like this file wants to come after this stuff, but all of this stuff needs to happen first. So I'll just duplicate that one section of code, either that or I create another file for containing all of those things. Man. I guess I'll do that. So that those are the test utils, and these are like shared test config.cpp goes right here. Boom, bang, bang, bang. Jeez, I hate that sound. Okay. And then if I go over to the shared utils again, I can just copy paste that stuff. The date is correct on there. Okay. So now anyone who needed that stuff can include shared test config.cpp up here. And so there's test main, and then there's history. Boom there. And boom there. Moopaloo, yeah. Whenever I catch myself saying I'll just have this duplicated, I go, do I really want that? And it's very rare that I do. It's almost always right to get rid of that. It's just finding the correct way to get rid of it that's sometimes tricky. But once in a while, after you've made the trade-offs, the duplication is the way to go. And that's when you wish you had a metaprogram generating the duplicated code. But in this case, I think just another file split will be fine. It's more files than I expected to have, but it's not really a problem. Like, it's not that big of a deal. That should go in the config file. Okay, and that puts us to just putting in the rest of the features to make this happen. So I need to do replay file name, and then I have to implement the function. Alright, so to make that happen, it'll be like right here at the very beginning, when I'm first initializing from all this stuff. Do replay file name, and I'll initialize both of those to 0. Alright, if we get that far, then the next thing I want to do is say, okay. So there's 1, 2, 3. So starting from I equals 4. If I is still less than the arg count, you plus plus on the I. And then if this is gonna be pretty weak system, but I don't care. It's a pretty weak system. This isn't really how you want to get command line arguments. It's a little more involved than this, but this is really all I need for now. Is what more of an abstraction? Question mark. What do you mean? Which thing? So if those two, if I find a minus h, then it's like, okay, we want to do replay equals 1. If I see that do replay is going on, and then at the end I'll say if I have a replay file name that is not equals 0, do replay. The copied code is, well, there's no copied code. I ended up not copying the code, but this code here was what I was going to copy. Was just some configuration stuff, like how I define these functions to like do these different things. It's pretty basic stuff, and the only way it would be duplicated is that two different executables would be compiling it separately, and really I want them to behave the same way, so I decided to just keep them in a shared spot. And then it turned out that this code and the code it was paired with needed to go in different spots. Like something needed to happen after this, but before other stuff that was. And these, like there was shared code, but between the two shared codes, I needed to put non-shared code. And so I was debating whether to make a small file for this or not, and I ended up making the file so that I can just include it. Okay, so if I am trying to do a replay, then replay file name equals argvi. Okay. And then at the bottom, and then after that, do replay equals 0. And if you already had a file name, then what you want to do is printf found minus h twice, ignoring duplicates, something like that. Alright. And then actually ignore those. Okay. So now the only thing we haven't done really is implement this function at the bottom. So the time has come. Moopaloo is asking about our previous conversation last time. We were talking about Visual Studio plugins, and you sent me a link. I looked around on that link, and it ended up just linking back to the thing I found originally. I can't really find what I'm looking for. Like, they have some really confusing documentation around that. I think the thing I want to do is called creating a tool. Like, they refer to that as creating a new tool. So I would end up trying to create a tool, but then all of their examples, like there's no link that's like here's how you create it. You have to go to their like really fucked up if you say that you want a new project, they say you can do this, and then you go to their templates and you're like, I want to do in other project types. And it's like the thing that's supposed to be in here doesn't exist. Like, I don't have it, and it might be a matter of like I don't have the right version of Visual Studio. Yeah, it could be a lot of things. It could also be that like it could be the year. Like I have 2013, I think, and I have the Community Edition, right? So I don't know if that's the reason I can't find it. Or it might be that their documentation's all wrong, and even if I could find it, it doesn't matter because all of the things are like, here's how you make a C# application. Here's how you make a basic application. There doesn't like appear to be a simple way of doing what I want. I could probably do a thing where I write a C# wrapper that calls up a DLL and then launches the plugin that's written in C++, but man, it certainly doesn't seem like they're set up to handle what I want to do. If you could find a better, like, proper example code to show me that actually you can compile and run, and it makes a plugin, that would make me feel more. That would make me feel better about Visual Studio plugins possibilities. So anyway, no, it won't error when there's no H flag. It's optional. Okay, so natural edits. Okay, so that's the thing I need a copy of. I'm going to bring it up here. Okay. Record log, stat log. Here's the log pointer. Here's the buffers. Here's the test repetitions. Here's the advanced data. There's the replay. Here's the scratch and the scratch size, and here's the record statistics stats out. Okay. Alright, so the next thing I need to do is sort of just grab one of my other tests. Alright, Emacs will refuse to paste it the first time because Emacs and I have this little ongoing discussion about whether or not things should work the first time you do them. Emacs is of the mindset that no, your editor shouldn't do the right thing at all times, and I, of course, I say that that's a load of crap. 1 minute. There we go. Gotta silence that. Alright, so don't care about this. Don't care about these. Actually, I don't even care about these. I kind of care about those. You gotta do it a certain way. Now what I'm gonna do is I'm gonna say I don't want to do any of the batch edits right now. Maybe I'll let it run with full natural later where it does edits and batch edits together. That'd be fine with me, but for now it's not set up yet, so I'm not going to run batch edits. I just want all of the normal edits, so I'll skip batch edits. And I want, I don't really care. I'll check that. I'm not it seems like I'm going to be running the same edits on all of them, and I know that the file ends up larger than it starts, so after all those edits run, you don't have less, like, it's always growing, which means you can repeat the thing on the same file without, like, doing a new file at a different location, so that's fine. So the only thing to do is say, when it goes to do the work, we need to know what an edit count is, and that comes from replay count. And it needs to be able to do, take the edit step. And this feels like something I probably want to put into the shared or abstract test. file. Edit void natural edits. It'll take a buffer type pointer. It will take the advanced data. It'll take the replay that we're doing. It'll take scratch memory and the size of that memory. And that's it, right? And all of this here just pops in over here. All of this goes over here. And then the step is the replay edits I, which I can really just make like a steps thing here. And all of this goes right there. So you grab your step and then you say, okay, what do I do with a step? I don't understand. But then after not understanding, you look around and you realize, oh, I just need to say step edit start, step edit end. Right, so that's like, we need the base string, which is strings. So take the base string plus, what do we want here? The base string plus the edit string start, and then the edit string length comes in after that, which is like that. And then, you know, just the advanced date of the scratch and the scratch size. Okay, so that applies all of the edits, but the thing is, like I said, I don't want to apply all the edits. I want to only apply child count. I only want to apply the single edits, so that ensures that. And I want to do it all at some specified offset. So that's like right in here. Here's the positional offset, which goes there and there. Okay. So then, to run this, I just do natural edits. I'll do buffers buffer, advanced data, replay, 0 for our position for now, the scratch, and the scratch size. There's a gap buffer. There's a multi-gap buffer. And there's a rope. Stream. Check test. It then tests that they're all the same. That seems reasonable. We'll do that once. Alright. Sure. And then the only other thing I want to do is say at each step here, let's do like I times some amount. So there'll be like, instead of zeros here, it'll be like, well, j is unused, so it'll be like j equals I times, and then it'll be like the buffer size of the first buffer divided by like 4 maybe, so we get just sort of about, or maybe 3. We won't even get through most of the file. That's not the plan. It's just to change the position each time so that you don't get any overlap from one to the next, and they all have to do as much work as possible to sort of simulate skipping through the file as you go. Let's see. What do we got? So edits is not a thing. I think I was talking about edits. I and J both lack declaration. Of course, it doesn't seem that I need both of them. It's more like just I. Okay. There we go. Okay. Yeah, none of this is stuff that I want. What I really want to do is close this. Close my Visual Studios down. Come on. Yes, there you go. Save that. Close it down. Alright, so then I can build, well, I want to debug experiment first. Don't know that this is going to work, so first I'll make sure that it works, right? And then we can actually run it as a speed test. Exited with code 1, huh? Okay. Not super. Not super. Uh-oh. argc is only 2. It wants 1, 2, oh, that should say 2, shouldn't it? 0, 1, 2. If it's no 0, 1, 2. Yeah, so 2 should be allowed. I sort of screwed that up. I must have changed my thought process at some point. So go back here. Less than 3 should be 2. I should start at 1, 0, 1, 2. It should start at 3. Okay, now I can put back in the stuff I accidentally deleted, and it should compile this time. Brilliant. Now that does remind me, since I screwed that up, luckily that reminded me that I need to tell this to do other stuff, including it needs a message that says, you know, hi, this is a message, right? And then it needs -h test out stuff. Test out stuff. Yeah. Awesome. Okay. So that's good. And then attack it with the F5, and there we go. Got something interesting. What did we get here? Test out stuff. Oh, right. I'm pretty dumb. I am pretty dumb sometimes, people. I hope you don't think of this as like useful, entertaining, but also educational information, right? 'Cause that's not what I'm providing. I'm not in any way providing education or useful tips or really anything that you want to try to learn from. I would suggest you learn from something else, not me, because I make the dumbest mistakes by not being focused all the time. It's like I don't even know what's going on. Okay, there we go. Alright, so that's kind of interesting. Oh geez. Wow, I knew there was something wrong about the math there. I was sitting there thinking this doesn't quite feel right, you know? 'Cause I'm saying that it shouldn't go past the outside edge of the file, but somehow the math isn't working out in my head. Now I've figured it out. Again, you should not take this as an opportunity to learn from me, because what I just did there was pretty stupid. If I'm going to keep it less than the file, the numerator has to be smaller than the denominator. If I is going up to this, as soon as it hits 3, it'll be a problem. So, you know, that required more thinking than I was putting into it. Alright, so we're finally passing, as in, like, it's not throwing a big fit at me. So now I can build it, and we'll run the experiment with the full gambit of information. So test file 1, that's the big one. Running tests, or testing the setup still is my message. I need prime replay.rpl. Give it a run. Alright, so now we're waiting for this test to finish up. It's taken 10 megabytes. It initializes a file from that, seeks to a position, seeks for words in the file, inserts stuff at the bottom, insert stuff at the top. Man, with all the stuff running with OBS and whatnot, that's much slower than it was. Delete at the bottom. It's only 25 samples for each of these things, so it's only 25 samples for each of these things, so there's a little bit of variability, but this variability is kind of nuts. Okay, that's also kind of nuts. It was a lot faster than that. Not sure what happened there, but that's interesting. At least I thought it was faster than that last time, but anyway. I think that it's definitely a matter of OBS slowing some stuff down. And I've got like 2 browsers. There's so much. I got Vim open still. So much going on. Let me take a peek. Yeah, I've got literally all of my cores spinning at nearly like 100% right now. So it's probably getting paged out more often, so we're not getting really reliable information here. I wouldn't want to stream me actually running this test, for example, but I'm at least getting proof that this kind of works. So if you look at the natural edits case, and again, this isn't really great data, so it's like whatever, but in comparison to everything else, the golden array is really struggling at that test, right? Like when you put it up against that, it's really, really struggling on all fronts, which is interesting because it doesn't struggle if you focus on one of the ends. Like it actually does better perpetually inserting to the top than it does here. Although that could be because we're doing more. Like this runs 100 edits. There might be more than 100 edits for it to do here, and so that's an interesting issue. But like the multi-gap buffer and the gap buffer are sort of just neck and neck. They're like pretty much at the same level there, with the gap buffer being just slightly better with the natural edits, and then the rope is, not so good, but it's way better than the golden array at that point. And you can remember this is doing like several hundred edits that jump around, and it's in a 10 megabyte file, so there's all sorts of concerns when you start doing that many edits about the golden array. But you'd think like, maybe the multi-gap buffer would do even better if I made the gap buffer jump farther. And to find out, I'd have to change the code up a little bit. So I want to investigate that possibility. Okay, so if I is that, we just got to say do like 1 plus the test repetitions, right? So it'll never quite take the end of the file. And then what we'll also do is say there's about 400 characters there, so if j is less than, or if j is greater than the whole buffer size minus 1,000, I'll give it 1,000 characters to sort of be a buffer there, because I don't think that we fill out that many ever, so in that replay test, so it'll be fine. Or we could even say in the is less than that minus the replay size, then j equals all of this, because it can't possibly go beyond that. No, it totally could. I'm just full of it. No, it couldn't. Yeah, the replay size doesn't really have anything to do with it, honestly. It's a little bit tricky because I'd have to do a loop to actually properly set that up and make sure that it never went over. The other thing I could do is just add the safety to natural edits. Say don't let things go nuts there. So let's do it there, because then it's just a little bit of code that I have to write. So test abstract. When you're about to do an edit, just before you do it, let's do a few tests. Let's make sure that dot start is well, we already know that's okay. Just make sure that the end is less than or equal to the whole size of the buffer. The size of the buffer, I'm not going to use that anywhere else. I'll just inline there. We go. Okay, I feel better about that. I'm interested to see, the whole point of this was to see if spreading out the jumps a little bit more favors the gap buffer or the multi-gap buffer more, because those are the two really good ones that it's kind of coming down to at this point. Let's run it again. So I don't think I showed this off while that's running, because I didn't bother to do what I should have done, which was shorten the sample counts on everybody else. Again, don't do as I do, but anyway, I don't think I've shown this off, which is the output from the program. Whenever I run it, it outputs a data file here where it, kind of gets a unique name by taking the date and time and putting those at the end of something, and then each can, it's set up so that we can sort of just put a computer name here and then a date name, and that way it's unique. And then I'll just get a bunch of these files once I start doing tests and stuff and putting messages. The message thing is so I can put in a message. It's like, oh, have done this optimization now, etc. And it just sort of marks up everything, not just the summary, but it has every single test instance, so that I can visualize data distributions, blah 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 blah. And that'll be fun to have as I go. I can say here's everything that came before this moment, and it'll be pretty fun to make the program that organizes all of that data and makes visualizations for it. So that I can really drill down into how all these things are working. See, that ran much faster for this multi-gap buffer than it did last time, where it popped up to 10 to some larger number of digits than it actually did. Let's see. It had popped up to 100,000. Alright. So, yeah, the golden, or the gap buffer, well, first of all, the golden array did much better this time than last time, which is a little weird. As compared to, like, the rope, which sort of, kind of sucked, but it also had a worst case, which is kind of always going to have. Oh, that would make sense. If you take edits randomly spread across the whole file, if you concentrate them all at the beginning, the golden array will suffer more. And as I spread them out across the whole thing, it's like its max is still the worst case, but it doesn't have, overall average. So where you put those edits matters quite a bit. But I think this is a pretty good, it should give a pretty fair distribution the way I do that. So I think this is a pretty fair test, since it goes across the whole file and sort of does what a programmer does, what I literally wrote in order to write the thing. And the coolest part is it's actually checking that all of the buffers are equal. So after each of these loops that does all those edits, it tests and it's passing. It's not finding any errors with the equality of the tests. So they're all testing out as streaming out forward and backward being exactly the same. Alright, so Moopaloo has sent me a response about the Visual Studio thing. Let me take a look. Develop Visual Studio, and the point, in case anyone watching doesn't know what's going on, is I mentioned at one point that I thought it would be cool to be able to make plugins for Visual Studio, namely a 4coder plugin to replace the main editor. And I said I had done some research, and Moopaloo is helping out because apparently has more experience with it than I do, because I have zero and don't understand it at all or know if it's gonna be possible. Interesting. Okay, so Moopaloo, this link, it looks like I'm gonna save this for later, but you've got here a couple of example projects that they aren't shipping anymore, but that apparently roughly still work pretty much the way they're supposed to. So for whatever reason, they've stopped shipping their examples of how to make extensions in C++ since 2005, but that's fine. I'll be able to hopefully track those down and get some examples, and maybe I can plug 4coder in. That would be cool. So anyway, yeah, I got that thing working, which is kind of the whole point. I'm not sure. I could work on some optimizations, but I'm sort of feeling like I don't want to start a new thing because I've got half an hour left if I go for 2 hours. I think now would be a good time to stop rather than starting something new. So I think I'm gonna cut it off here. But thank you everybody for coming to the stream and for supporting 4coder and all that. And I'll probably be streaming again next week. So keep looking out for that. Also, it'll be sometime in the next week or so that I'll be finishing up the buffer experiment, and I'll probably do a full proper, well, I'll definitely do a full proper write-up, and I'll probably do like sort of in-depth look into my various implementations and the details there. I might do some bonus streams as well to stream my optimization process on those buffers. It could be about another week or two, because if I spend a lot of time to optimize some things that I have in mind, it could be a while. But I want to wrap this up, so it'll be in the next couple weeks that we finally get the results from the experiment. So thanks again for coming, and see you guys later.